Hi, Sergei, founder and CEO of 100XBio. And today I will be talking about my personal pain points while I was a scientist running experiments, which I hope our technology can solve. I remember myself not being such a great scientist. 10, 15 years ago, I was making a lot of mistakes running experiments, and one of my big issues was I liked experimenting, which hurt me because I like to tweak the protocols. I tried to simplify them, I tried to cut corners and make them shorter, I tried different concentrations, sometimes to save money, sometimes to save time, and eventually I either failed those experiments or was unable to reproduce them. So it is important to be very consistent when running experiments. And one certain story there was when I had a 10-day experimental plan, and those 10-day experiments I could not obtain replicable data, and I complained to my colleague, amazing immunologist. I asked him how you handle those longer experiments, and he told me, Sergei, if you want to run them well, you need to be fanatical about following every tiny detail the same way every time you run this experiment. And this advice helped me so much. It fixed my experiments, but also made me think, wow, if all our normal experiments would be done fanatically, identically, in a fanatically identical way, we probably would have more reproducible science overall, because reproducibility is a great issue of all biology experiments. And this also makes me think that one single protocol ran in the same lab by two different people can be run like two different experiments, because it is written in the protocol, pipette gently or pipette vigorously. People will read it differently and do it differently. And another problem that I was facing, and many other people facing who I interviewed tens of immunologists, and they say, yes, we do have these 14-hour, 16-hour work days, and sometimes it's just impossible to make this work shorter. And I believe it's not only increasing the chance of introducing some errors, because people are getting tired, getting exhausted after 16 hours of work, but also it is just not healthy, and it is not good for people to do this monotonous work this long. And interestingly, into industry, those experiments mostly are modified, and they are fitting 8-hour work days. And what this is teaching us is that actually maybe some experiments have to be long. Maybe they have to take 16 or 24 hours. It's good for experiment, but bad for an operator. So if we could automate experiments, we not only can make them more consistent, more resistant to errors, but also we can optimize for data and for experiment, not for humans who run them. And another interesting thought that I have about collaborations, I really loved setting up collaborations, and I really loved seeing that the project is getting in, multiple labs involved. But when I'm thinking of large collaborations, let's say multi-center clinical trials, or large company having many dozens of labs, if they are running experiments even with the same equipment, it is hard for them to pull the data and analyze it as one. So I think of laboratory automation as a potential way to have a network of instruments that maybe runs 100 experiments, but later we can analyze it as one experiment which is done in a standard way, and we just having it done at a large scale, instead of collecting all the tiny mistakes and errors a little bit to the left, a little bit to the right, and hoping that it will lead us to some ground truth, which is not guaranteed. And so wrapping up, I believe that laboratory automation can solve first of all, it can help people who may be very talented in coming up with great ideas, great hypotheses and experimental plans, but lacking technical skills. It can help them start running those experiments well right away. It can help get more reproducible data. You can have 10 years of training, still struggling with reproducibility. Third, it can help us more reliably pull the data from multiple labs. And eventually, I can also identify one problem with laboratory automation. Laboratory automation is now mostly built for, first of all, labs that have a good budget. It is traditionally expensive, but second, it is done for the tasks that are very repetitive, standard, and simple. Because this is where you have this certain thing done 100 times in a year, 1,000 times in a year, 10,000 times in a year. It makes sense to make it high throughput, to make it fully automated. But when we're looking at a lot of discovery type of work and even translational type of work, there are a lot of variable experiments which are extremely hard to automate. If someone runs them only once a month or twice a month, everyone will be, oh no, we don't see that high ROI in automating those experiments. So we are trying to build a tool that is adjustable to multiple different types of cell-based experiments, where when someone already have prepared their unique cells, unique reagents, this part, it's so much harder to automate. We're not even touching that. But if they have cells and reagents ready, they can load into our machine, run their experiment with just one click if they already have the program set up. That's a dream of the equipment that we're building, and eventually this can lead to the large networks generating data 24/7. And at the same time, if this tool is very compact and small and easy to build and use, then it can be put in thousands of academic labs and help academic science to become more reproducible and help students spend more time on actual science, hypothesis generation, and thinking instead of monotonous pipetting and excelling at their technical skills. Because I was myself this PhD student who probably wasted half of the PhD time trying to make my experiments technically perfect while I couldn't, and I struggled with that. I hope this video helps to understand what we're building and why. Thank you so much, and until next time, bye-bye.